Hi guys, it's Ashraf from WiZ.edu, and today we're going to be going through some examples on compound angle formulae. So to get started, we are asked to prove that cos A plus B plus cos A minus B equals 2 cos A times cos B. So obviously we're going to start off with the left-hand side because it's the side our compound angles lie on, and it's the more complicated side. So we'll just apply our expansions for these compound angles, which is, in the case of cos, sine, and a change in sign, right? So cos A plus B will turn into cos A times cos B, and now we change the sign minus sine A times sine B, and that's going to be all added to cos A times cos B, and here because there was a minus we changed to a plus sine A times sine B. Now you can see some of our terms here can cancel out because we have a minus sine A times sine B here, that's negative, and we have a positive sine A sine B here. So we can cancel these two terms off. So we are left with these two cos A times cos B terms, and those added together will give us 2 cos A times cos B, which is the right-hand side. So we've solved the question. Now we go on to our next question. And in my opinion, this is quite a difficult question as it requires quite a few steps and also involves quite a bit of algebra or simplifying of expressions. So how you'd approach a question like this, obviously, is we're going to start on the left-hand side because it's our complicated side with our trig functions, and we told that it all has to equal this number here. So the only way you can get a 20, a 40, and an 80 to equal a number without using a calculator, obviously it's assumed in this situation because we asked to prove something, we can't use a calculator. The only way you can do that is by making use of your special angles, right? So our first step in a situation like this is always going to be to rewrite some of these angles in terms of our special angles, which are 30, 45, and 60. And also what you'd want to do is get these angles equal. So while we're rewriting in terms of our special angles 30, 45, and 60, we want to get either a 20, a 40, or an 80 in all of them. So hopefully they'll cancel out somewhere down the line when we're simplifying, or we can apply some of our formulae to combine them, or a Pythagorean identity somewhere. So the best way to work this question is to rewrite sine squared 40 as sine 60 minus 20 all squared. That becomes sine squared 60 minus 20. And as you can see, 60 minus 20 is the same as 40. And we'll do the same thing for sine squared 80. We can rewrite it as 60 plus 20. So it will be sine 60 plus 20 all squared, or sine squared 60 plus 20. So that's how we're going to rewrite these to solve this question. So let's write our left-hand side out. That's going to be sine squared 20 degrees, okay, plus, I always like to keep these in brackets because we have a square here, and when we apply the compound angle formula, we don't know a compound angle formula for a square of a trig function. We only know it for a trig function to the power 1. So that's why I like my square brackets. That's going to be plus sine. We said this would be 60 minus 20. And that's all squared, right? So we have sine squared 20 degrees plus, now we have our sine compound angle here. So we know our pattern for sine is sine cos, sine, same sign, right? So we'll apply that formula here, and that's going to give us sine 60 degrees times cos 20 degrees, and our sign remains the same, so we still have a minus there. Cos 60 degrees times sine 20 degrees, right? And that's going to be all added to, now we'll do the next bracket, which is contained in my square bracket, sine 60 minus 20. That's going to be sine 60 degrees times cos 20 degrees. And now our sign will stay the same. That's going to be plus cos 60 degrees times sine 20 degrees. And I just need to remember to put my square brackets all around this and square it. So you can see this has become quite complicated, and it's going to be quite a mission to take this apart and expand it. So what I'm first going to do is put in all our special angles, because we see the 60s over here and we know the value for the trig functions of 60. That's going to be sine squared 20 degrees plus sine 60 we know as root 3 over 2 times cos 20 degrees minus cos 60 we know to be half times sine 20 degrees. Okay, that's going to be plus, open our next square bracket, sine 60 again, root 3 over 2 times cos 20 degrees, and that's plus cos 60 again, that would be half multiplied by sine 20 degrees, and this is all squared. So now the main issue we're going to have is expanding these squares, these squared terms here in the middle. That's the main issue we're going to have. So what I'm going to do is I'm going to do this one here in this color when we expand it, and this one, let's say, in black. So you can just see where everything comes from. So let's start with our sine squared 20 up here, just going back up for space. And now we're going to plus, right? And now we square each term. Root 3 over 2 all squared. Over here, root 3 over 2 times cos 20 degrees all squared. And that's going to be minus 2 times root 3 over 2 times cos 20. Remember, we're multiplying by 2 because that's our expansion for the square over here. That's going to be multiplied to half sine 20 degrees. And then finally, we add the minus half sine 20, and we square that last term. So we've squared our first term, we've squared our last term, and we've multiplied 2 times the 2 terms. And now for the next square bracket, that's this one over here, we're going to say plus, the first term is root 3 over 2 times cos 20 degrees. That's going to be all squared. Now we do the same thing. We say plus 2 times our first term, root 3 over 2 times cos 20 degrees times our last term, half sine 20 degrees, right? And then we add the square of our last term, which is going to be plus half sine 20 degrees all squared. Now you have to look closely, but some of our terms are actually the same here. So our root 3 over 2 here is repeated over here. This big term over here, right, is the same as this one over here, except this one has a minus 2 over there, and this one has a plus 2 over here. So these two terms are going to cancel out, right? So the rest of them we can just open up and then simplify. So let's go ahead and do that. So this is all going to be equal to sine squared 20 degrees plus, we're going to square that term over there. That'll become 3 over 4 cos squared 20 degrees. And then we'll square this term over here. That's going to be now plus a quarter sine squared 20 degrees, right? And that's going to be then plus another 3 over 4 cos squared 20 degrees plus 1/4 sine squared 20 degrees. And now we can add our terms up here and simplify. That's still sine squared, but we have a couple other sine squared terms. We have this one here, and this one here. So 1 plus a quarter is 3 over 2. So that's actually going to be 3 over 2 sine squared 20 degrees plus our cos squared terms. We have 3 over 4 there and 3 over 4 there. So that's also going to be 3 over 2 cos squared 20 degrees. Now we can take 3 over 2 out as a common factor, and that becomes sine squared 20 degrees plus cos squared 20 degrees. And this is perfect. Why? Because sine squared of two of the same angles, we can use the Pythagorean identity and replace that with a 1. So that gives us 3 over 2 times 1, which equals 3 over 2. And this was our goal. So we've solved the question, and 3 over 2 is our final answer, as it's our right-hand side. Our next question is much easier. All this does is requires you to identify the pattern here. And what is the pattern? We are asked to simplify sine 75 times cos 15 minus cos 75 times sine 15. Now, if you see a sine times a cos and a cos times a sine separated by a function or a plus or a minus in the middle, you immediately think of your sine compound angle formula. Because what's the pattern of the sine compound angle formula? Well, it's sine cos, cos sine, same sine. So we see this pattern here and can immediately equate this to sine 75 and 15 over here. And we know that with the sine compound angle formula, our sine stays the same, right? So that minus here becomes a minus here. And all this here is equal just to this here by just recognizing your pattern. So you finally make this sine 60 degrees, which is root 3 over 2. So you can see how something that was so complicated, it was 2 terms in fact, can be reduced to such a simple form if you just recognize that pattern. And now for a final question, we are asked to simplify cos theta plus 2 cos theta plus 240 degrees. Now you can see we have our compound angle here, and remember your pattern again. As you saw in the previous example, it's quite important to know your patterns, especially for the reverse, as we just saw. So I'm just going to repeat the pattern again over here. For cos compound, it's cos, cos, sine, sine, and a change in sign over here, right? So we can simplify this as being cos theta plus 2, and now just put a bracket here because we are expanding something, and that 2 will have to be multiplied in. Apply the formula cos theta times cos 240 degrees, so cos cos, change the sign. Now we make it sine theta times sine 240 degrees. Now we can further simplify this to cos theta plus 2 cos theta times cos 240 degrees minus 2 sine theta times sine 240 degrees. Now what we can do from here is take the 240 and apply our reduction formula so we can get a numeric answer, because we know that 240 is 180 plus 60 and 160 is a special angle. So we'll go ahead and say that's equal to cos theta plus 2 cos theta times cos 180 plus 60. So we can use our supplementary reduction formula there. Sine theta times sine again, we're going to make that 180 plus 60. That's going to give us cos theta plus 2 cos theta times, now 180 plus 60, because it's a supplementary angle, S for supplementary, S for same, that becomes cos 60, right? But always check the original. Now cos 240 over here is in the third quadrant, and we know the cos is negative in the third quadrant, so that's going to be negative cos 60. That's going to be minus 2 sine theta times sine 60, and sine 240 is also negative in the third quadrant because sine's only positive in 1 and 2. So now we can replace these with our special angles over here. So that's going to give us cos theta plus 2 cos theta. I rather take out the negative in the first place. So just erase that there and take the negative there. So it'll become minus 2 cos theta times cos 60 is a half, right? And that's going to be plus now, because I'm multiplying in my negative, 2 sine theta times sine 60 is root 3 over 2. So this 2 will cancel over with this 2 here, which will leave us with cos theta minus cos theta plus this 2 will cancel out with that 2, root 3 sine theta. So our final answer then, because these 2 cos thetas cancel out, would be root 3 sine theta.